Hello everyone and welcome to our first project. In this project we will integrate a pH probe to our PIC32 microcontroller. An analog input we will convert into the readable value that will be displayed on the LCD. We will use the analog conversion and we will use the I2C protocol. We have some pH buffer solutions that will help us to calibrate the probe and get some trusted values out of this. So, few things to be done. Let's get to it. For this project we will copy the previous project that we've created, LCD. I'm gonna go right click, copy, and I'm gonna just name it. Maybe in here I'm gonna type in pH_LCD. Let's copy. Once the project is copied, I'm just gonna create this one as my main one, set as main project. Then I'm gonna close this main file, go to the source file, double click on this. Right, so this is the file from our LCD setup. Let's go to Harmony, embedded, Harmony configurator. Let's wait for it to load. I've got the Harmony configurator loaded. Now let's go to peripherals, analog to digital converters, ADC 0. Let's add this to our project. I'm gonna click on it. Okay, and then let's check if all the parameters in here are correct to our project. I'm gonna expand all of these options. Okay, I'm gonna leave this as it is, this one as well, so is that. In here our reference is going to be external voltage reference A, so I'm going to select that. I'm going to leave it on the free run. Then in here, positive input, we will use pin 4, analog input pin 4. Okay, and the rest of it we can leave as it is. Okay, let's have a look at the pinout now. Let's go to MHC tools, tools, and then pin configuration in a pin table, or actually we can go to the pin settings. Now in here we can see we've got our reference A already, and pad 4 is already been selected as analog, so it's good to check if everything is set as it should be. We got our I2C from the previous settings, which is good. Okay, let's go to the project. Actually, let's create the code, generate. Now let's go to our main C file. In here, with this file, this is quite big. We've got loads of instructions for the LCD. So what I'm gonna do is I will move those instructions. So instead of scrolling up to the variables and then down to the main section, we just have what we need. So give me a second. What I have done is I have created a new LCD commands .c file as well as header file. So I've included that in here. And in LCD commands and LCD files, this is what we have. LCD commands.c, I moved all of the instructions, so all the code is included in this file, all of the code files, just from the main C file. And commands is just a quick explanation of the codes, the header file. I will make sure to include all the files on my GitHub, so you can download it all and see it's working. For the time being, let's go back to our main file. I'm just going to build the project, just make sure that it's working fine. Yep, okay. So it's built. Now this is working correctly. I have added some code lines in here. We're going to talk about this in a second. But essentially now this is what we have left. It's much easier to work with, to have everything almost there in front of you. So maybe first let's go to our board and I will explain what are we using. In here I have our board. Now we know the connections, I just relocated them. So this is I2C going to our expander, and I'm going to use a 4x20 LCD for this project. In here I've got already some connections. I'm going to talk about those connections in a second. Reset switch, and we're taking 5 volts from this board. So this is our setup from the previous project. Let's see what we're going to be using. So this is a PH board and the BNC connector for the probe. I have soldered those connectors there, so it's easier to work with it on the breadboard. Okay, and this is our probe. It comes in with already some distilled water inside. I will put this board, these connections in there. So I will put it, make sure that this is our voltage, ground, and then PO is the output of the pH tester, pH probe. Okay, so the connections in here are like so. Right, I'm gonna place this here for a moment. Let's go back to the code and let's talk about some of the new lines. In here I've added some more variables that are related to our pH measurements. So our raw pH, converted voltage, the actual pH value, and there is a conversion value which is calculated as 25.34. If you want to read more about this, there's everything on the net how this value was obtained. You will be questioning why is this plus 00. We're gonna talk about this in a second. LCD buffer. Then in here we've got the we're starting up all the modules for our PIC, selecting LCD, initializing the LCD, enabling our conversions, so the conversion is happening all the time, and 1 second delay. This is just for everything to stabilize. I have nothing in our while loop, so at the moment nothing's gonna be happening. Okay, now to set this project up, let me just type in a few lines. The probes that I've added are LCD go to, so we're going just to the beginning of our LCD and we type in measured pH. This is gonna stay there forever, it's not gonna be changing. In our loop we calculating the raw pH from the analog to digital converter. Volt pH, it's gonna be the voltage converted from our analog converter input, and we will print that value on the LCD. Okay, and then we go there to the 14th line, which is straight after measure pH colon, and that value from the buffer is going to be displayed 2 seconds delay, so we don't so we see this value a bit clearer. Now let's program the board. The first thing we have to do before we use it is we need to calibrate the our device. So I'm using a 5 volts reference from the board, which is taken from this pin in here. So for that to be calibrated, I'm going to be looking for the value of around 2.5 volts. We need to connect both of those sections of the probe input. I'm using the tweezers to connect the inside to the outside, and we can see that the measured voltage is around 3.23 volts. So what I'm going to do is I'm going to take my small screwdriver, and this potentiometer is going to control our voltage value. So by turning this, we will be adjusting the voltage. So I'm going to go this way, and I can see it's not going down, it's going up. So I'm gonna go the other way, and I'm looking for a value around 2.5 volts. It doesn't have to be very close, that precise. I'll leave it there. Okay, 2.54. Happy with that. Our voltage of 2.5 displayed on this screen is almost comparable to pH of 7. So now we can go to our board, to our code, and let's convert this value, because this is actually, it says measured pH by its actual voltage. Let's convert this value into the actual pH value. To do that, I'm going to add some lines, and again we're going to talk about them. What I've added is the actual pH value to be calculated from our volt pH. So this is the formula to calculate this value, and now we're going to be printing on our LCD that actual pH. So the only thing that I've changed is I've added that, and I'm printing this to the buffer instead of the volt pH now. Let's program the board and see what's happening. And it's complete, so let's reset. What's happening here is actually the values that come in here are not able to be calculated. So I'll place this down. I will connect the probe, and then we should see some values on the LCD. Okay, this is a distilled water inside, so the value should be about 7. Let's reset the PIC, and what I see here is the value of 6.6764. If you want, you can wait a little bit longer for this to stabilize, and you can see, you can have the actual value. What I would like to show you is just the different values on different fluids, as well as how are we calibrating that value in the software. So let's make an assumption that I'm expecting this fluid to be a value of 7. Yes, but this is just an assumption. To calibrate the pH probes correctly, we should use something like buffer solutions or ready mixed solutions for calibration of pH. I've got these buffer solutions, and I've got them already mixed in here. This is not the most accurate one, but for this project this will do nicely. So let's have a look. This is a chart. I'm going to use a pH of 6.86 first. Now in my location is about 20 degrees, so I'm expecting the value of about 6.88. Let me take the bottle with the 6 solution. Okay, let's place it here. I'm going to open it up. Now unscrew the probe. Okay, place it here safely. Before I dip this probe into the solution, I will use this water, which is just a clear water. Every time, just clean your probe, not to contaminate any fluid. Okay, I'm happy with that. I'm just going to wipe it with a paper towel. The probe is cleared, so I'll place it into the solution. Okay, and according to our chart again, I'm expecting to see about 6.88. Okay, let's give it a moment to stabilize. So the value is around 6.65. Okay, I will call it about 6.6. So from 6.6 to the value of 6.88, as we established before, I'm looking to add about 0.2 28. Let's go to the software. In here, if we scroll up, then we see this 0.0. This is our calibration value, as we've said. So now I'm looking to add about 0.28 to the value. This is still quite precise because we're talking about 2 decimal places, and I'm happy with that. It is still, if there is a fluctuation of 0.1, we still should be happy. So let's go ahead and let's program that. Let's send this in. So I'm quite happy with this value, how it come up. Okay, 6.93, 6.9. This is very close to 6.88. I will leave it as it is in here. Now let's go and clean this probe in water. Just for the comparison, let's have a look in here. Using the 4 pH solution, pretty stable at that temperature, so I need to see about 4. Okay, after a moment we can see the value is very close to 4. I'm happy with this. And now if you want to measure some fluids, I've got here the pH value is around 7, so we're ready to start our measurement. This is just a normal water, and I've got in here some lime juice, and I will add this to the solution, and well, let's observe how the pH is dropping. So I'm just going to slowly add a few drops. Oop. Okay, and immediately we can notice that the pH is dropping quite rapidly. 4.44. Let's mix it. 3.3, 3.2. I'll add a little bit more, and then it's going to drop to the acidic value as much as it is for the lemon water. There we go, it's still dropping. So with this project there is one more thing that we could do. If you see, for instance, that your values are fluctuating quite a lot, top to bottom, there is a few lines of code that we can add to stabilize those values. This is pretty stable, I would call it, but nevertheless, let's go back and let's see the code. This is our new while section. So this is actually the formula to calculate the median. This code, just like the code for the pH I found on the internet, and then I've adapted it to work for our PIC microcontroller. So what it's doing is actually calculating the median value and is giving us the most stable value that we want in here, and just have every value will be displayed every 2 seconds. So let's program our PIC. As we can see, this is around now 2.9, 2.9 to 2.8. Let's add some clear water, dilute this solution a little bit more. Okay, we can see the pH value is coming up slowly, but not too much, as it's still the solution is acidic. Let's go back to the clear water. Clean it, and we can see that it's creeping up to the normal pH. So this is it for this project. Thank you very much for bearing with me. This is the first one, and I'll make sure that for the next ones I'm a little bit more prepared in terms of how this board is going to be rigid. A few improvements definitely on my side. Thank you.